Good morning, students. Welcome back to our chapter number 7. That means what we were discussing triangles chapter. We had done types of congruencies and we had discussed about exercise 7.1 application of certain trigonometric congruency in triangles. Now today we come down to properties of an isosceles triangle. All of us know what is an isosceles triangle. All of us know the properties of an isosceles triangle. Isosceles triangle, two sides of a triangle are equal. And on the basis of that, you have theorem number 7.2 and 7.3. What does it say? Angles opposite to equal sides of an isosceles triangle are equal. Isosceles triangle we all know. Two sides are equal. So the angles opposite to equal sides of a triangle are equal. When we draw this isosceles triangle, say this is a triangle A, B, C. AB is equals to AC. Angles opposite to equal sides of an isosceles triangle. Opposite to this AB and AC, opposite to AB, which is the angle? Angle C is equals to angle B. That is your theorem number 7.2. It says if two sides of an isosceles triangle are equal, the angles opposite two sides are equal. And 7.3, just converse of this. The sides opposite to equal angles of a triangle are equal. If two angles are equal, then the sides opposite to them are also equal. That is the property of isosceles triangle. We all know, we have been using it since lower classes. Clear? Now today we are going to discuss about these two properties and apply the congruency of triangles using these two properties. So we are coming down to exercise 7.2. Page number 123, exercise 7.2 of your textbook, question number first. What does it say? It says, in an isosceles triangle ABC with AB equals to AC, the bisectors of angle B and C intersect each other at O. This is an isosceles triangle ABC, with AB equals to AC. AB equals to AC. Definitely, if these two sides are equal, angles opposite to them are also equal. So, angle B will be equals to angle C. Yes or no? What is given to us? We are given isosceles triangle ABC in which AB is equals to AC and bisectors of angle B and angle C meet at O. And what does he want us to prove? There are three things he wants us to prove. The first one he proved that OB equals to OC. OB equals to OC. And secondly, he wants us to prove that AO bisects angle A. Sorry, not C, angle A. So let us complete the figure by doing certain construction. What construction? He says bisectors of angle B and C. Bisector, what does the bisector mean? Dividing the angle or dividing the side into equal parts. That is what we call bisector. So this is angle B. So with the half, angle B is equals to angle C. Why? Because AB is equals to AC. Two sides are equal. So angles opposite to them are also equal. Theorem number 7.2. Let us write it. Let us write it in triangle ABC. AB is equals to AC given to us. So therefore angle B is equals to angle C. So why? Angles opposite to equal sides of an isosceles triangle are equal. Angle B is equals to angle C. That is, angles opposite to equal sides are equal. Right? Angle B is equals to angle C. And BO and CO are bisectors. Bisectors of angle B and angle C. So that means this is BO, this is CO, intersecting each other at O. Will this two be also equal? So therefore, angle half of angle B is equals to half of angle C, because complete angle is equal, so their halves are also equal. I number the angle number 1, 2, 3, 4. That is, angle 1 is equals to angle 2 is equals to angle 3 is equals to angle 4. Any problem? So observe now, in triangle BOC, can you see this triangle? Angle 1 and 3 are equal. In triangle BOC, angle 1 is equals to angle 3. What does it say? The sides opposite to equal angles of a triangle are equal. Opposite to this angle 1, which is the side? OC. Opposite to this angle 3, which is the side? OB. Angle 1 is equals to angle 3, so therefore OB is equals to OC. Write down the reason. Sides opposite to equal angles are equal. Any confusion? OB is equals to OC. Simple application of the theorem number 7.3. Then he says, show that AO bisects this angle A. Join OA. Correct? We need to prove that this angle is equals to this angle. So can you see these two triangles are congruent? Can we apply congruency in these two triangles? And how? Is AB equals to AC? Number 1. Is OB equals to OC? Proved. And is this AO common? It is a part of both the triangles. We can also use SAS. Sir, how? AB is equals to AC, OB is equals to OC. And can you see angle 2 and 4? They are the included angle. Is 2 and 4 also equal? Yes, sir. So we can use SAS as well. Now, in triangle AOB and triangle AOC, AB is equals to AC given to us. OB equals to OC proved above. Here we have proved. And we can see this AO common to both the triangles. AO equals to AO, that is common. So therefore, triangle AOB is congruent to triangle AOC. By what congruency? SSS. All three sides are equal. So therefore, angle number 5 is equals to angle number 6. So therefore, angle number 5 is equals to angle number 6. Reason CPCT. Therefore, AO bisects angle A. It is bisecting this angle A completed. Simple question. You can also do it by SAS as I told you. But since in the beginning itself we had done all the properties of congruency, we can directly use it. Okay, it's not an issue that sir we have to use it by the same property. No, you can use it by any property. You can solve it by any property. Take a look at second question. Same kind of question. In triangle ABC, AD is perpendicular bisector of BC. Perpendicular bisector. We know what is perpendicular and we know which is the bisector. In triangle ABC, AD is the perpendicular bisector. Perpendicular bisector means BD is equals to CD. This is what it means. Show that triangle ABC is an isosceles triangle. We need to show that it is an isosceles triangle. Very simple. What is given to us? We are given AB is the perpendicular bisector of BC. What we have to prove? We have to prove that triangle ABC is an isosceles triangle. That is AB equals to AC. This is what we have to prove. Construction not required. Everything is constructed. Can you see two triangles? We can see triangle ADB. Are they congruent? Can you see equal sides in them? Definitely. Is this BD equal to CD? Yes, sir. Is this AD common? Yes. And is this angle equal? So what congruency? Side, angle, side. And if two triangles are congruent, will the respective side be equal? In triangle ADB and triangle ADC, BD equals to CD because AD is perpendicular bisector given to us in the question, right? Angle ADB equals to angle ADC equals to 90 degree, and side AD is equals to side AD, that is common. So therefore triangle ADB is congruent to triangle ADC by what congruency? Side, angle, side. SAS. And if these two are congruent, is the side AB equals to AC? So therefore AB is equals to AC. Reason CPCT. Therefore triangle ABC is an isosceles triangle. Clear? Properties of an isosceles triangle, we have used it in lower classes. Here we are just applying them. Nothing new. Take a look at question number 5. Very, very simple question. Question number 5. In the given figure, ABC and DBC are two isosceles triangles on the same base BC. This is a triangle ABC, isosceles triangle, and this is another triangle DBC, isosceles triangle. Both of them are isosceles triangle. If they are isosceles triangle, two sides are equal, then angles opposite to them are also equal. So take a look at this triangle ABC. Two sides AB and AC are equal. So will this angle be equal to this much? Angle number 1 will be equal to angle number 2. Similarly, if triangle DBC is an isosceles, will this angle be equal to this one? Angle number 3 is equal to angle number 4. What is given? Given isosceles triangle ABC and triangle DBC on same base BC. What we have to prove? We have to prove angle ABD equals to angle ACD. Construction not required. Proof. As you can see, it is an isosceles triangle, so we can clearly state, sir, in an isosceles triangle, if the opposite sides are equal, then angles opposite to them are also equal. So that is what we have to write. In triangle ABC, AB is equals to AC. So therefore, angle number 1 is equals to angle number 2. Equation number first. And in triangle DBC, DB is equals to DC. So therefore, angle number 3 is equals to angle number 4. Equation number second. Adding equation first and second, we are adding both of them. So therefore, angle 1 plus angle 3 is equals to angle 2 plus angle 4. Check the figure. Angle 1 plus 3, is it equals to ABD? So from figure, angle 1 plus angle 3 is equals to angle ABD, and angle 2 plus 4 is equals to angle AC. Hence, only thing required is your observation. Clear? Rest of the questions are also same. Let us discuss these questions one after the other. Take a look at question number 3 and 4 now. They are similar to each other. They are similar. You can see, if you observe them, you will see that the figures are same. Figures are same. There is no change in the figure. The only thing changes is the question. Something is equal to something else. Alright, I will draw both the figures for you on the board so that you can identify both the questions are same figure wise. Let us draw question number 3. In the given figure, it says ABC is an isosceles triangle. This is the triangle A, B, C. The first thing he says, ABC is an isosceles triangle, so that means these two sides are equal. In which altitudes BE and CF are drawn to equal sides AC and AB. Altitudes BE and CF are drawn to equal sides. So these are the altitudes, right? Show that these altitudes are equal. So what is given to us? We are given isosceles triangle ABC in which AB is equals to AC. What we have to prove? We have to prove that BE is equals to CF and BE is perpendicular to AC and CF is perpendicular to AB. This is the thing given to us. And this we have to prove that the altitudes are equal. Okay, whereas in question number 4, if you observe, he says, read it carefully, figure is same. A, B, C. He says, ABC is a triangle in which altitudes BE and CF, two sides AC and AB are equal. Altitudes are equal. This is BE perpendicular, this is CF perpendicular, they are equal. What is given? What is given? In triangle ABC, altitude BE is equals to altitude CF. And what you have to prove? Read it carefully. What you have to prove? He wants you to prove triangle ABE congruent to triangle ACF, and secondly AB equals to AC. Can you see? Here it was given to us that AB is equals to AC. Here he wants us to prove. Here he wants us to prove that altitude B and CF are equal. Here it is given that altitudes are equal. Can you see the figures? I have marked. In this question, the side AB is equals to side BC. AC. Here the altitude CF is equals to altitude B. Can you see? Both the question figures are the same, but there is a big difference in what is given and what is asked. Yes? So let us solve them. Let us see what do we observe. The most important part in geometry is observation, students. You just have to observe carefully. If you observe it, there is no issue. Clear? Take a look. He says isosceles triangle ABC. So that is isosceles triangle ABC A, B, C. This is an isosceles triangle. If two sides are equal, angles opposite to them are also equal. Angles opposite to equal sides of an isosceles triangle are equal. So let us write that first. In isosceles triangle ABC, AB is equals to AC. So therefore, angle ABC is equals to angle ACB. Write down the reason. Angles opposite to equal sides are equal. This angle B is equals to angle C. Right? Any confusion? Okay. Now observe. We want BE equal to CF. So observe, where is BE? This is BE. And this is CF. Yes or no? Yes or no? So observe it very carefully. Take a look at triangle BFC. In triangle BFC and triangle CEF. CEF. BE BFC, I'm shading it for you, slight shade, and triangle CEB. Can you see that? In both these triangles, one angle is 90. If I talk about first BFC, so angle F is equals to angle E, that is 90, given to us, they are perpendicular. Then, can you see, in triangle BFC, this complete angle B is coming, and in triangle CEB, this complete angle is coming. Angle B is equals to angle C, proved above. Here we have proved. And is this side BC common? BC equals to BC, that is common. So therefore, triangle BFC is congruent to triangle CEF by what congruency? AAS. And if these two triangles are congruent, is this BE equal to CF? So therefore, BE is equals to CF, reason CPCD. Triangles are different. When we come over here, construction not required here as well. Proof. Only thing we have to do is to check the correct triangle. Alright. He says these two are equal. So he is telling us that two triangle AB and triangle ACF. In triangle ABE and triangle ACF. Where are these triangles? ABE, can you see this? And ACF, can you see this? So can we see this angle in common? Which triangle? ABE, can you see this? And ACF, can you see this? One angle is common. Angle A is equals to angle A, that is common. And angle E is equals to angle F. Angle E is equals to angle F is equals to 90. And can you see this side? BE equals to CF. BE is a part of this triangle. CF is a part of this triangle. BE is equals to CF given to us. So therefore, triangle ABE is congruent to triangle ACF by what congruency? AAS. And if these two triangles are congruent, is the side AB equals to AC? So therefore, AB equals to AC, reason CPCD. Can you see? In both the questions, figure is the same, but the triangles that were taken are separate. Here it was ABE, this triangle, and ACF, this triangle. In both of them, the figures are same, but the triangles that are taken are different. Clear? I hope these two questions are done. Once you do it on your own, that time you will be able to differentiate them better. Alright? Take a look at rest of the questions also. 6, 7, 8, they are not difficult questions. They can be solved directly by you. It is not a big question. Sorry. ABC, question number 7. I am not going to solve it. You can do it. Question number 7. He says ABC is a right isosceles triangle. Right isosceles triangle. Right means one angle is 90 and isosceles means two sides of a triangle are equal. I am talking about question number 7. Question number 7. I am not going to solve it. ABC is a right isosceles triangle in which angle A is equals to 90 degree. So these two sides are equal. Yes or no? Because automatically we know that sides of a hypotenuse is always equal. Find angle B and C. If two angles are equal, two sides are equal, angles opposite to them are also equal. Yes or no? Theorem 7.2. If these two angles are equal, let them be as x. What is the sum of angles in a triangle? 180. In right triangle ABC, AB is equals to AC. So therefore, angle B is equals to angle C. Let it be as x. What is the sum of angles in a triangle? 180. So therefore, angle A plus angle B plus angle C is equals to 180. Angle A is already 90. plus x is equals to 180. So x plus x 2x plus 90 comes over here, 180 minus 90. So x is equals to 90 upon 2. So therefore x is equals to how much? 45. Any problem? So angle B and C both are how many degrees? 45 degrees. Simple question. Yes? Correct? Question number 8. Show that angles of an equilateral triangle are 60 degrees. All of us know equilateral triangle. All sides are equal. All sides are equal. A, B, C. Equilateral triangle A, B, C. This is given to us. Right? What do we know? We know, sir, angles opposite to equal sides are equal. Sir, if these two sides are equal, are these two angles also equal? Let them be as x. And if these two sides are equal, these two angles are going to be equal. Because AB is equals to AC is equals to BC. So therefore angle A is equals to angle B is equals to angle C. And let them be as x. So what is the sum of angles in a triangle? 180. X plus x is equals to 180. So 3x is equals to 180. So x is equals to 60. I hope it is not difficult. Clear? Correct? Take a look at question number 6. Figure is given to you. You just have to prove it. In question number 6, he says, in the given ABC is an isosceles triangle with AB equals to AC. ABC is an isosceles triangle in which AB is equals to AC. AB is equals to AC. Okay. Then he says side BA is produced to D such that AD is equals to AB. Side BA is produced to D. BA is produced to D such that BA is equals to AD. Okay. Then show that angle BCD is right angle. BCD is right angle. This angle we need to prove 90. What is given to us? We are given isosceles triangle ABC in which AB is equals to AC and BA produced to D such that BA is equals to AD. What we have to prove? We have to prove that angle BCD is equals to 90 degree. BCD, that is combination of these two angles. Construction not required. One after the other, just take. Proof. We know in a triangle, if two sides are equal, angles opposite to them are also equal, right? In isosceles triangle ABC, AB is equals to AC, so therefore angle ABC is equals to angle ACB equals to x. This angle x and this angle is also x. Because two sides are equal, angles opposite to them are also equal. Take a look at this triangle now. Now, in triangle ABC, AD is equals to AC. AD is equals to AC. Reason? Because AD is equals to BA. AD is equals to BA and BA is equals to AC. So therefore, AD is equals to BA. AD is equals to AC. AD is equals to AC. So therefore, angle ADC is equals to angle ACD equals to Y. This angle is Y. Any problem? Two sides of this triangle were equal, so these two angles are equal xx. Two sides of this triangle were equal, so these two angles are equal. What is the sum of angles in a triangle? In triangle B plus angle BCD plus angle D is equals to 180. Angle B plus angle D plus angle BCD. How much is angle B? X. How much is angle BCD? BCD. Is it equals to both of them? That is X plus Y. And angle D is Y equals to 180. X plus X, 2X. Y plus Y, 2Y is equals to 180. What is common? 2 is common, so X plus Y is equals to 180. 2 is common, so X plus Y is equals to 180 by 2. So therefore X plus Y is equals to 90. So look at the figure. From figure, angle BCD, that is equals to X plus Y is equals to 90. Hence proved. Any confusion? So these are the students. This is the exercise. Very easy. Only related to your two theorems 7.2 and 7.3. That is the properties of an isosceles triangle. Angles opposite to equal sides of an isosceles triangle are equal, and sides opposite to equal angles of a triangle are equal. Please practice these questions. You can very well solve it. Now only last exercise is left based on congruency of 7.3 RHS and SSS. Last exercise 7.4 is eliminated from your syllabus this year. So this year we won't be doing exercise 7.4. Thank you everyone. Please practice them.